So just a couple ground rules. If for some reason starting to speak too fast, you guys make like this. For Kenneth, talk slower, okay? So let's make a quick test. So if you talk too fast, you guys have to do. So, okay. Thank you. So are we typed yet? The evolution of Gradual typing in Mypy. Let's see. So who is speaking with you? So my name is Caio Salgado. I'm a backend software engineer. I have been coding for my life for living for the past 10 years, more or less, a bit more than 10 years. Currently, I'm a developer at Exonius, part of the developer. I live in Porto for almost a year, but if you can check from my accent, I'm from Brazil. Anyway, so a little bit about myself is that I never liked static typing. So I'm doing this talk, right? Actually, I recently started to like static typing, right? So during my career, first I started with C language, and it was horrible. I cried. It was not nice. A lot of types, not much help, and I almost gave up. But then I found something better. I found Perl. No types, no nothing. Lots of fun, lots of errors. But then I found something even nicer. I found Ruby. That's for me. I was very happy. I was no typings again, and lots of things to do. And if you see I'm going in a nice direction, where can I go next? And I went to JavaScript. And that was not that fun, but it was crazy. Lots of different things, a lot happening at the same time. And from that, I went to TypeScript. And TypeScript, there were some nice things there, some interesting things. And by the time you might be thinking, oh, I touched some languages, but where's Python? So I always touched Python. Every time, there was also a bit of Python everywhere, doing something like with pandas, data science, or scripting, or something else. So finally, now you see I'm happy, because I'm only coding Python, and that's nice. Okay, so we are talking about types, right? So I was working with TypeScript, right? And what's nice there is that I had this whole idea of code completion. I don't know the APIs, I don't know everything. I have an idea, and the idea to dot and autocomplete. I open brackets and I see all the options. Here now I'm scrolling up and down, and I can see the different signatures of the function. I don't need to put a keyword argument here. I know every time I type, the IDE, in this case VS Code, is telling me what I'm typing, what it is, right? And actually, VS Code is from Microsoft, TypeScript is from Microsoft, so they made the integration awesome. So it worked very well right from the start. This idea, I don't know the documentation of Luxon, but I don't need. I just go typing and I go testing. This, for example, this fetch, right? Where fetch is a JavaScript common API, and you can see there's even the MDN reference there. So if I want to know documentation, just click there. It takes me to the website. Here, even this API, and something interesting here is that I know the types, I know the name of the things, but for example, here I'm making a request to the weather.com that doesn't make much of sense. And it's for today, I look at the different functions. Oh, I want ISO something. I just type ISO, it autocompletes fuzzy finder. It's awesome. So I get everything. And here, for example, I get this wiggle line. I hover it, and I can see, oh, you're calling a function. So, okay, this doesn't expect a function. Let me put brackets. It even suggests to me, hey, put the brackets. So that was nice. Hey, this is a very nice thing that TypeScript has, right? This is cool, right? Never saw this before. What can I get from there? Nice. So that was a very good experience I had. And okay, how can I get it more? How do I want that, right? How can I get it in Python? And yeah, here is something very nice. For example, I'm typing process. I see the other options. I say, hey, I found my library too. Automatically imports for me, right? Then I open brackets and say, okay, process data waits some list of integers. Okay, let me give you a list of integers. And what is the result? I don't know. Let's check. I type the result and result and see, okay, oh, I just opened the call and see, oh, it's already giving me options. So, okay, so I give all these numbers, give me the totals. Oh, it also gives me the average. So, oh, let's make some calculations. What else can this do? Oh, there's a fast. Why not? Fast, true. Fast is a Boolean. I want this to be fast, right? I don't know what it does, but I want it fast, right? Okay, so I get these completions. I getting these types. I don't know what process type does, but I can see and I can navigate it with kind of errors. I'm looking a lot through the signature. I found there's like some extras there. Okay, let's try that. And I just type extras. It opened up. So I open the brackets and it adds from like median. Oh, so nice. So I can also get median. But that was not there before. Well, how come? Oh, hey, now it is. So I add extras. I add median, and like this whole environment that I'm in tells me, okay, now you have median. Awesome, that's nice, but what is the type of median? Like, it has to be float, right? What it is? I just type A, something, any variable, and I can see the type. So, awesome, but what if I remove the median, right? Swiggle line, so, okay, right now, like, I'm not getting the error, right? So, not getting it, like, the IDE is telling me, hey, this variable does not exist. It depends on that thing there. So that's very nice. You can see this dependency, and you're like, if you don't know the API, if you don't know things, or if you're playing around. That's a nice thing to learn. I love to do that to learn, like playing around, try things. And the IDE gives this quick feedback. I didn't run any code yet. I'm just typing, and I can see what's going on there, right? Yeah, for example, there's the surprise. I just type it and say, hey, surprise is not a required key. So actually, all the time, I'm using a dictionary. Result is an ordinary dictionary, right? But I type it, it has a lot of types, and lots of inference can happen inside VS Code here. And I get this kind of thing. So if I have surprise, okay, we are on type. I can use like, I can get surprise. I can say, hey, surprise exists. Instead, before using it, I can just use check if it's there. Wait a moment, I'm going to get there. And okay, does surprise exist inside this condition? Yes, it does. The swing line removes because it knows the conditional, removes the other type. So that's awesome. Like I don't need like to remember that's maybe there. The conditional gives me that. So it's a lot of power there. It's very nice things. And what else I do there? Oh, also there's another function, get user info. I type it, hey, give me the ID. Oh, nice. Like a database query, right? So okay, give me the user. And again, like I just type the user, red line. I get like what it is there. There's age, okay? Age is red, so everything's red, okay? Age is not known, attribute for none. Okay, so user might be none. It's different because this time user is a identity model, right? So the errors are different. So okay, let me work inside a block again, so I can work like this won't happen because I'm sure the user exists here. And also, I'm using PyIdentity. I'm using a lot of that PyIdentity does some runtime checks, and also is lots of types there to help you. And I can just like go around and see the user. Like, hey, the user has last name. Also, something nice I noticed here, like there's name and there's last name. Like that's kind of bad, right? So I can just hover the name, go for example to here, just pass like F2 to rename. Like I'm using Copilot. He also gives me some options, and I changed the name, but what about the API? Like I changed the usage. What's there? So I go to the definition, and in the definition, I find the user profile. Inside the user profile, I can see that it changed the first name there, right? So given I'm using all these types, and there's all the things inside, in this case, PyLens, all this infrastructure, I can change types. I can like change an attribute, and it changes everywhere. It finds all the reference to it and changes all of those. And also, again, I have some navigation inside the user, because user.bakeaccount.cards, and so forth. Nice, so that's awesome, right? Why I want that, right? That's great for me to get things. And you see, like, one of the biggest things here, the biggest wins I have here is the new Python, new references, right? There's this guy, like Tony Howard, he's the guy like who invented Quicksort, the guy who invented Quicksort. So he had this talk in QCon, I believe it was in 2009, right? And one of the main takeaways he gave here is like, this is interesting, like this is my interpretation. But like, new pointers, like you're giving a freedom to the user, hey, like this is easy to code, easy to give, I'm gonna give you this freedom that something might be there or might not be there, and you go and handle it, it's easier. But it's points like the user, the developer, doesn't always like, is right? He doesn't know. I need to give him boundaries. I cannot give you the freedom, right? Sometimes I give you this freedom, he doesn't know how to use it, and lots of issues happen, and you get like the $1 billion mistake of having no references. I don't know. So, okay, how does, can you get Python to take it? Like, how did you make Python get these types? How does that work, right? So, I found the history, and you have to start small, baby steps, right? We may fall sometimes, but getting the types correct. So I did a little digging, and back in 2006, I found for Python 3.0, the function annotations. It's just like, hey, this is annotation. This is not like typing of that. It's just like we want to, how was it? We want to provide a single standard way to specify information, like annotation, like how to do it, right? I do a little digging. I don't know exactly how PEPs work, but I found the commit that changed the state to accept it, and it was 2007. So created 2006, approved 2007, and 7, 8, 9, 10, 11, 12. 5 years later, 2012, I found this first commit of Mypy, right, in GitHub, from Yuka, probably saying his name wrong. And the idea was like Mypy is at MyPython, right? It's MyPython. And they started Yuka create like I'm creating a new adapter for Python, a new interpreter for Python, right? And it's going to be a different language, right? That's going to work similar to Python. And I did a little more digging, and I found that in his blog, like not digging, but just clicks. That 2 days later, he created this blog post and created the first one. Hey, like I'm creating this. I'm using this post to update it. And then I took a look at the history, like he made some posts there. And this was 2012. At 2013, he went to a PyCon California, and there he met Gradual and Army Ringo from PyPy, had a lot of talks, and said, hey, like, PyPy is awesome. And you know, you have this annotation thing that you don't use, so perhaps you can use Mypy to use that. By the time, like, Mypy was not like conformant. I'm already 2 minutes in, there's a lot in, so I'm gonna go a little bit faster, sorry. And a couple more times later, they got the PEP for type hints, right? The draft. In 2015, an idea in Mypy, like the main guy there, and that's it. Like we got Mypy, we got typing, and that's also like I'm gonna concentrate everything on Mypy. But other companies were there. I saw this podcast with Guido, and there was Lex Friedman, and he said a very nice quote. It's like Mypy being an open source project with a very small number of maintainers was successful enough that people said that the static type checking stuff for Python is actually worth investing in for our company. But somehow they choose not to support Mypy, making Mypy faster, say, or adding new features to Mypy. Both Google, Facebook, and later Microsoft developed their own static type checkers. So we got Google with PyType, we got Meta with Pyre, we got Microsoft with PyWrite, right? PyWrite is the one I'm using there. That's cool because, like, if you open a Python file and say, hey, why don't you use PyWrite? Like PyLens, that's PyWrite, but plus a bunch of things. So we get 4 type checkers, 3 made by big techs. Like, that's all type checker we need, right? No. First thing, like, some people may be saying, hey, I don't use types, and I have all these features for some time. Because, yes, like, if you use PyCharm has a lot of different things there, and he does also works a lot with, like, trying to infer types, trying to infer what you're doing, and how different things work, right? I found the other guys also, I'm not going to talk about it, but it's based on Mypy, is a fork of Mypy. There's PyLizer, also a different one, and why not do it in Rust, right? Everything's in Rust. So there's also PyLizer, right, which, since it's Rust, the page already say, hey, I'm the fast one of all the type checkers, and okay, that's nice. Demo, do you have time? No, there's no time. Okay, so adoption, like that's the talk. So I found this article. This is from 2020 about like the usage of the types, and it looked at like 20,000 pull repositories on GitHub, open source, and here's some data from that. From all the things that are typed, most of it, the majority are user defined, so they're classes that users define them, right? Then like have stir and none, basic things, and you can select the most one is complex. So most things that are typed either things that people created, right? Developers created. And from where is all this typing? If you can see there, that's the returns, the parameters, and the assignments, right? The assignments is very little use. Most of things in params, except none. There's one thing of Mypy, like at least in VS Code. If you have a function, but you don't type the return value, Mypy doesn't ignore the function. Okay, I want to look at it. So if you just type none, then you get all the type going there. So that's my guess for why there's, for none, there's so much typing in returns. And this is the hard truth, at least from 2020, the logarithm scale of the number of files, right, with annotations. As you can see, the huge majority has 0, right? no typing at all at the file. And that's go smaller and smaller until you have like a bump in the ones that have plus 100. Right? So the majority of code, I can say like there's very little type or no type, but there's in the end, like there's a lot of people that use types. This is for repositories, right? So from 2678, and again, like you can see more clearly, that's some guys has a lot of typing, right? So I want to reference here like a nice, very awesome book that I read. I'll give you some ideas on that. This book from Luciano Ramalho, Fluent Python, and going very quickly here, he gives like this idea of duck typing, goose typing, static typing, and static duck typing. That's something new, right? Python started with duck typing. It's like, what is that? Like, I don't care. Like, if you do here, there's no. I can call alert with any of the instance of bird, instance of duck, instance of goose, and there's no syntax error. The code will run, but you're gonna get a runtime error. It's only in the runtime is gonna have error, and the idea is that you just need to if you have this function, if it works, that's it. Into 2.6, we got goose typing. Goose typing is like, hey. For example, here is the tree of inheritance here. So, for example, if I want something that is a container and I have something that is sequence, I like say something inherits from the different one. He say, okay, so like the duck is the sequence inherits or the way around from container. So I know like a container behaves as sequence. So we have this goose type is 2.6. And here's an example. For example, the bag is a sequence, right? And since it's a sequence, I can use how big I am. It's going to call len. To be a sequence, here the only construct methods you need to implement is getItem and len. So you get these two. So I can run an interval if it doesn't implement inter, but it has getItem, so Python handles it. So that's nice. Then we have static typing that we start from 3.5. And here, for example, I can see like, hey, I can strictly give the type, and I can before compiling, right, the type checking can tell me, hey. We have an error here, like it does not work. And in 3.8, we got like the static duck typing. Is like you have the typing, but you like tell it. You make it explicit. For example, I'm telling, hey, there's things like the support quack, right? And they just have the quack method, and then everything that you can say like you can type it with support quack. So anything that has that method will be a duck, right? In this case, support Mac. Doesn't need to have that inheritance chain. Okay, and that we get some bonuses. For example, here on the right, I can add like this runtime checkable in the protocol, and then what I get, I can do like existence. So something that's completely typed, right? There's no like value there, runtime value. Now I can do like this instance check, right? And for the other way around, I can say, hey, getItem, so I can type it now. I can say, hey, this is the size, this is the interval, yeah, and this is like works for the abstract class, right? But you see that there's a strict line there, so there's some issues there because like it works. I run this code, it works, but Mypy cannot tell like because that bag is an interval because it does not implement inter. But it doesn't matter. Like Python, if it sees the object has getItem, it will behave as an interval. Like it does that. So Mypy is not there yet. So one thing that is brought in that book is that sometimes you need to know like PyType ignore, right? Because it's not there yet, right? It doesn't run a function. And okay, something very interesting there that he brought also was that the typing of max function, right? Max is a simple function, right? You just give an interval, right? Or just give like two or more arguments, and you're going to give the maximum there, right? There's also the default value and the key, the function to run it. So it's kind of easy. Like if you see this, you already know like the API, right? Max for tree, max I can pass a function to get, so I like inverted it, and I have a default. If I get an empty list, I get the value that I set at the default, right? So let's type it. This is the typing. Just the types, not the implementation of the max function, right? I got this from the book, and you can see like we have this dynamic nature in Python, like for the max, it works in different ways. And if I want to type it, this is all the code the amount of code I have to work, right? In order for that to work. For example, you don't see the missing or empty message being there because for default you can have anything. And how can you tell anything from nothing? So you create this missing object and it compares, hey, did I receive, do I have missing or not? So do I have the default or not? So this is what you have to do. So one of the idea that Luciano Ramalho brings is that If you start using, or if you want to have static typing and everything, that's going to change how we write Python, right? That's going to change all this dynamics, everything I can do with that, right? There's this quote about like, although it is hard to express the signature of Max, it fits one's mind quite easy, right? In my understanding, that expressions of annotation makes it very limited compared to of Python. So the annotation, how to express it, is not good. That's their point, right? Because that's make you code different. Like that's, you want to have a max. You have to type everything. There's a terrible example of showing that is the request library, because request like it's awesome the way it works, the API. And one of the parameters of request is the files, and this is the piece of the files that I look there, like to implement just one of the arguments to make it work. And this is one I get from the Fluent Python book. Like this was the piece he used back then just to check the request, right? The files. And you still have those headers there. So it's huge just to type. So if you want this dynamic, to be dynamic, as Python like are used to, you have to do a lot of typing, right? And it gets worse. So I have a couple of friends that code TypeScript, right? And we have some chats to conversate. And a friend of mine was very angry. He showed me this. Hey, I got a type error here. I cannot read it. Like, what the hell is this, right? I do not understand anything that's going on here. So there's also this thing like you want to represent everything. You want to handle the word, right? But then, like when an error comes up and it's not usable, right? You don't have much work to do with that. And there's also that touch me, like being from real life. There's some lies here. This is a piece of code that I changed from where I work, and you can see like I have roles like get entities. Okay, this is a generator. I have a tuple and a dictionary. Okay, nice. It's kind of odd, like existence, row of dict, the type is already saying, what does check? I don't need to do that. So just yield entity and let's go. And let's go, errors. Then our alert system said, hey, like you get 89 times 0 to less for hours. And because we try to get like none, we try to use get on none. So this typing is a lie. So you have static typing, and this is also something from that paper. That a lot of projects have types, they use types, but they don't run MyType. They're not running any type checks. So they use that from the IDE for the developer experience, but not like as a check to see if the code's working. They just add it like to help them while they're typing. And yeah, that caused some bugs. There's a book that I like very much that I also work with Ruby. This book from Sandy Metz, and there's something that he tells that is very nice, I like it a lot. Is that like static and dynamic typing both make promises, and each one has costs and benefits. Static typing aficionados cite the following qualities, right? The compiler unnerves type errors at compile type. Visible type information serves as documentation, and compile code is optimized to run quickly. There's a lot of things to say that. And okay, but if you want these qualities, right, you have to make some assumptions. You have to, in order to get those things, right? So you have to assume that, have the assumption that the runtime errors will occur. They will happen if you don't have a compiler, right? And the programmers will not understand the code unless you have those type, right? And the application will run slowly if you don't have that. So is that the case? And who likes dynamic typing will tell, hey, the code is interpreted, dynamic loaded, like there's no compile make. Just run it and you get feedback, you just have those steps, right? And the source code does not include type information, and metaprogramming is not include type information, like it's easier to see things, like it's clear, like they try to make the context. And if you want to do metaprogramming, if you do crazy things that help, that creates a nice API that helps your users, it's much easier to do that way, right? Your typing is not going in that direction. And if you believe those things, like these qualities, right, then you overall the development is faster without the compile type. That makes sense. The programs find it easier to understand code when it doesn't contain type declarations. When I was typing C, the types getting my mind, was not helping me, right? And you want metaprogramming, you want that power, right? And conclusion. Is there a conclusion? So the idea is like typing, there's a lot of language that uses typing. And how does it work? Like that helps on other things that help with all this checking. There's some people say about other languages strictly type it, and you get all this behavior that tells you, hey, your code are correct, your code works. But there were some references here about like, hey, sometimes typing is just testing. Why don't you run tests? Why don't you add tests, right? If the things you're trying to get are bugs because you didn't forget a type, you didn't check for no, why didn't you have a test then? You didn't test anyway sometimes, so why you're not doing that? And one of my points here is that when I point the good things, I didn't put, hey, bugs did not happen. Bugs happen with typing. And the good things that we get there is not, in my opinion, what I'm trying to say, convince you is that we get the developer experience, right? I get the experience on my IDE, right? I don't need to go to the documentation. I have a lot of things there for me to tinker, for me to play with, right? It's not that I want a fast compiler. It's not that I want not to make bugs. And these things will happen. It's not because of types. So the typing idea, is, in my point of view, is not much of the confidence of my code. It's something for me to develop it faster, to have more confidence, and be happier coding, right? I'm happy with C, and I'm very happy with Python. And I get even more happier with all these features, right? All these things that we can get from that. And yeah. Guess what else? Oh, there's some references that I didn't say. And questions?
Hi, great talk. I had a question about the study that you mentioned about the repositories using type hints and all of that. Do you know if they also analyzed docstrings? Because there's many ways in which you can type a function just through a docstring instead of annotations.
Yeah. As far as I look here, no. They only look at the typing, strictly typing, or typing in the files, or like the PYI file. So they didn't look at that. So there's, yeah, there's something that you can look, because as I said, like PyCharm, if you have docstrings, you have typing, you have that safety, you have all those features, right? And so yeah, that's improvement for the code. But yeah, they didn't look at it.
Another question I had, like, what do you think about many of these tools? You can override the type of a function return, right? So let's say some function returns a typed dict, but I can type the variable as just a dict, and I'll lose all the type information. Do you think these tools should kind of, let's say, inherit the type? So okay, if I'm typing a variable as just a dict, but it can infer from the function that it's a typed dict, then it won't lose that information. Or we just shouldn't type the variable at all because the function is already telling us what type the variable has.
Yeah, so that's a great question, because like this is something that sometimes in my work I have, because sometimes like I'm using VS Code, so I'm using PyWrite, right? And if I rover some variables, PyWrite will tell me, hey, this variable like was not defined. Like if it sees the variable is all caps, right? It says, oh, this is Python, this is a constant, right? That means here's a definition. The definition, hey, this is a string. And not showing, when I hover, it doesn't say, hey, it's a string. He gives me the value of that. And the type he gives me is like literal in the value of the string. So I rover it and I know the type, like what's reading there, right? Much more than type, I know exactly what's there. And I have some friends that are, but if you just type the constant with stir, then you lose that information. Like if I'm on PyWrite, we'll hover it and say, hey, this is a stir. But what's inside there? I don't know. But if you're using PyCharm, it doesn't care. You hover it and show the definition, gives you the line and everything else, so you don't lose that. So that, for now, I would guess is dependent on the type checker you're using, right? For example, my type, if you put something that is, you have a variable and you put that, you have a list of integers, then you put a stir there, a string there. Mypy is going to say, hey, this is any, this is a list of any. While if you run the Google one, like PyCheck, I believe, it's going to tell, hey, this is a list of a union between a string and an integer. So that's dependent on the type checker.
Any more questions? No? Thank you, Caio.
Thanks.
And now,